Okay, you guys. Well, so today we need to work on writing the different versions of quadratic that we know. Okay, so at this point we know standard and we know vertex. So if you read kind of up here at the top, where we start here, where I'm highlighting right there, how do we determine if it's better to write an equation in standard versus vertex form? Okay, so let's take if we're given a graph and we look at it. Okay, so we're learning about what's given, like what's easy to pick out of the graph. Well, if I look right there and right there, I can see the zeros. So that's pretty easy to see from this. I can also, I think that's a perfect point right there for the y-intercept. Okay, but if I look at the vertex, that's somewhere in between 0 and -1 and somewhere after -3 on the y-axis. So I'm not really sure about that one. So I'm not going to say I know the vertex perfectly from that one. So in this case, mainly because I know the zeros, okay, I should be able to turn this into standard form. Okay, so if you're given a graph, all right, and you've got the zeros, it's probably going to be easier to turn that into standard form than it is to vertex form. Okay, you can probably figure that out from the name. But we'll kind of look at how we do that here in just a second, because look over here. All right, if we look at this graph, well, if I look, the two zeros are a little off, so I don't think those are really easy. Y-intercept is somewhere off the top of the graph, but look here. Vertex, pretty easily found at 3, -7. So that's really the best thing that I see here is the vertex. Okay, I mean, I could pick out some other random points, I guess, maybe, like that point at 2, -5, or at 4, -5, maybe I could pick those out, but those are just random points. So really the biggest thing that I can see is the vertex. Okay, so I would want to write that in vertex form. Why? Because I'm given the vertex. Okay, so now I need to know how to do that. All right, so let's start with this example. It says write the equation of the parabola that has zeros of -2, 0, and 4, 0. Okay, so like pretend you saw that on the graph. Well, you'd see the two zeros, and like we just talked about up here, that's for standard form. Okay, so we're going to decide to write that in standard form because we have the zeros. Okay, now what we have to do here, okay, is think about how we got to the zeros in the first place when we learned to solve these. Well, remember that for standard form we factored them like we did the Xbox, and we came up with these, or we did quadratic formula and got these. Okay, really we should be able to turn these back into the factors. So I really want to work backwards. Okay, so I'm going to write that right here. I'm going to work backwards. Okay, so in other words, if these are the factors, if x is -2 and x is 4, if I work backwards, well then to make it equal to 0, think about what I would do right here. Well, I'd add 2 to both sides so that those would cancel and make 0, and this becomes +2. So one of my binomials, right, is x plus 2. Okay, and then the other one, same idea. Since it's positive 4, I would subtract 4 from both sides. So this would end up as x minus 4. So then the other binomial is x minus 4. Okay, so then you can use whatever method you like. Remember double distribution. You could use full. You could use the box. There's a box over here, so I'll use it to multiply those two together to get the equation. Think about all those things that you've learned. Okay, so x plus 2, x minus 4. Okay, so x times x is x squared. All right, x times 2 is 2x. -4 times x is -4x. And -4 times 2 is -8. Well, remember, we're always looking for like terms to combine here, and we have them right there. Okay, so if I'm going to write this in standard form, I'm going to start with my y equals. Okay, you could put f of x equals if you wanted to. All right, but x squared, combine the two like terms, so -4 and 2 is -2, so -2x, and then -8. And there you go. You've taken the zeros, you've put them back into their binomials, right, by making them their opposites, by kind of working backwards and making them equal to 0. Then we multiply those two binomials together, and there we go. Okay, so that one worked out okay. Look at this one, though. So again, write the equation of the parabola that has zeros of 1/2, 0, and 6, 0. Uh-oh, fractions, all right. It's okay. We have the zeros again, so we're going to do standard again. Okay. So again, we're going to work backwards just like we did before. Okay, so if this is a positive 1/2 right here, right, we would have to subtract 1/2. Right, so then right here would change this into to x minus 1 half equals 0. Over here, to subtract the 6, so x minus 6 equals 0, right? All I'm doing is just finishing that equation, just kind of working it backwards so that it equals 0, okay? But then there's something to watch out for here, all right? And it's this one. So if I put x minus 1 half, like that, into parentheses, like so it's a binomial, okay? It's not standard, really, to have that half in there. So we want to get rid of it, okay? So the way you get rid of it is whatever the denominator is, okay, then just multiply the entire binomial by that, and that'll clear it out. So essentially I'm distributing a 2 here and a 2 there. So then what that changes it to will become 2x. Well, then it'll be minus 2 over 2, which is then just minus 1, right? It's negative 1 half times 2 will be negative 1. So half of 2, a negative half of 2 is negative 1, okay? Then the other one, well, the other one is just x minus 6. So that one's okay. But those are the two you want to use. You always want to clear out a fraction. It's more standard to have it that way, okay, to figure out what the equation is that matches those zeros, okay? So now we have our two binomials to multiply together. So 2x minus 1 and x minus 6. Again, I'm going to use the box. You can use your preferred method if you have one. So 2x squared there. Let's see, that'd be negative 1x. This is negative 12x, and then positive 6 right there, right? Okay, so then looking for like terms here. All right, so then if I'm going to write that one, I got y equals 2x squared minus, that's a terrible squared too, you guys. Sorry, hold on, let's go back and fix that. There we go, that's a little better. Minus 13x plus 6. All right, and there you go. Now you've written the equation from those. All right, so that's not too bad. Just kind of work your way backwards, put in the binomials, and then use skills from previous units that, again, you already know. All right, so then let's look down here. Okay, now it says write the equation of the parabola that has a vertex of 2, 5 and passes through the point 3, 7. Okay. Here's your key right here. Right? You got a vertex. If you have the vertex, write it in vertex form. And again, I like this because vertex form is pretty simple to plug things into. Okay, well, I'm going to go ahead and come over here and let's see. That vertex is 2, 5. If you think about what that is, right? Remember, this is your H and your K. All right. But remember to write it in the equation. We want that phrase that I talked about before, opposite H, right? So I'm going to go ahead and fill in the vertex in my equation over here. Okay, so I want y equals, well, I don't know my a yet, but I can fill in the other stuff. I know that x is always there. So then opposite h, all right, so h is 2. So make that minus 2, squared, always squared. All right, it's got to be quadratic, so it's got to be squared. And then k is 5, so plus 5. But what am I missing? I'm missing a. Well, I need it, right here. I've got, whoops, not right there. That's standard form. I want vertex form right there. So I'm missing that a. I've got everything else. Okay, well, we learned our good Desmos trick, right? Where we could run the regression. But to do that, we had to have 3 points. How many points do we have here? We only have the vertex and one other point. So the other way that I showed you, okay, was to do this, was to substitute and solve for a. So notice the x and the y have been substituted as the 7 and 3. They come from this point right here. Okay, right? This is, the 3 is the x and the 7 is the y. So in the formula, right, that's what they took the place of. Notice the 7 took the place of the y, okay, right here, and the 3 took the place of the x. You got to make sure you put those in the right spot, okay, otherwise it's not going to work out right. And then, of course, the h and the k, see, like we did over here in the part of the equation we've already written, okay, I had the minus 2 and the plus 5. We got the minus 2 and the plus 5. So everything's in the right spot, so now we just need to solve it for a, okay? So we need to, let's see, we need to do parentheses first, right? So let's leave the 7 alone, leave the a alone. 3 minus 2 is 1. Okay, leave the 5 alone. Now 1 squared is 1, so that's really just 1a. So it's really just a plus 5. So subtract the 5. And it looks like a is 2, so not a big deal to do that. Okay, so did the parentheses, squared it, and then subtracted the 5, and there's our a. So if we come over here, we put 2 in there for a, and we've got our finished equation. It's in vertex form right there, and there you go. Okay, so we can do that. Not too bad.